All right, let's look at how we graph a quadratic that is in vertex form. Vertex form is y is equal to a h minus x minus h squared plus k, where the h comma k is the vertex. Do this the same way as standard form. Well, we're looking for the same information as in standard form, but it is done a slightly different way. So does the graph open up? If a is positive, opens up. If a is negative, opens down. The vertex, h comma k, and identify if it's a minimum or a maximum. The axis symmetry, which is just x equals h, equal to the x coordinate of the vertex. The y-intercept, by substituting 0 for x and solving the equation for y. And then the y-intercept gets reflected to create the graph, and then the domain and range. So let's look at the first example. Y is equal to x plus 1 squared minus 5. All right, so first we want to identify not the a, b, and c, but the a, h, and k. So a, So a, come on. Oh my gosh. A, h, and k. The a, and remember the equation y is equal to a x minus h squared plus k. The a is the number on the outside of the parentheses, which in this case would be 1. So a is 1. The h, x minus h. So in order to get x plus 1, if we're minusing h, h would have to be negative 1, because x minus negative 1 becomes x plus 1. The k is negative 5. Since the a is positive, this opens up, which means that we have a minimum. The vertex is h comma k, so negative 1 comma negative 5. Axis of symmetry is just x is equal to h, so h is negative 1. The y-intercept, we substitute 0 in for x, so y is equal to 0 plus 1 squared minus 5. So 1 squared minus 5. So 1 minus 5, which is negative 4. So the y-intercept 0, negative 4. This is all that I need in order to graph this. So the axis of symmetry is at negative 1, so I'll put an imaginary line here at negative 1, so I know where to reflect. Negative 1, negative 5 is our vertex. Our y-intercept is 0, negative 4, which is right here. I can reflect this to get another point on the other side, and then I can connect these to make my parabola. And now I have my graph from vertex form. The domain is all real numbers, or you could write that as negative infinity to infinity. The range is the y values that are greater than or equal to negative 5. That could also be written as negative 5 to infinity. And we have all the information that we wanted to graph from the vertex form of the equation. Alright, so let's take a look at this second example. Y is equal to negative 1/2 x minus 2 squared plus 6. The a, b, h, and k. A is negative 1/2. H is 2, and k is 6. Remember, we're looking for these from the equation ax minus h squared plus k. So this opens down because the a value is negative, which means that we're going to have a maximum. The vertex is just h comma k, which is 2 comma 6, which means the axis of symmetry is just the x coordinate, x is equal to 2. The only thing that requires some work to find is the y-intercept, so y is equal to negative 1/2. We're going to substitute 0 in for x, so 0 minus 2 squared plus 6. So negative 1/2, that would be negative 2 squared, so 4 plus 6 Negative 1/2 of 4 is negative 2, so negative 2 plus 6, which is 4. So the y-intercept would be 0, comma 4. This is more than enough to graph it. This is exactly enough to graph it. We'll put a imaginary line at 2 for our axis of symmetry. We will plot our vertex on the axis of symmetry 2, 6, which is right here. The y-intercept is 0, 4. We'll reflect this point to get another point on the other side, and then we will connect these to get our parabola. Our domain, of course, is all real numbers, or negative infinity to infinity. Our range, y is less than or equal to 6, or negative infinity to 6. Good. We have everything we need from there. All right, so got two honors. Page 57, numbers 10, 11, 12, 13, and page 58, numbers 10, 11, and 15.